Rakib Hassan, and today my topic is friction of materials. Before going into any deeper, let's first know what is friction. Friction is a force that resists the sliding or rolling of one solid object over another. As friction is a force, there will be a direction, and the direction of the friction is opposite to the direction of motion. There are five basic laws of friction that we should know, and they are pretty much self-explanatory. So I will just say the five laws. The amount of friction is proportional to the normal force exerted between the surfaces. Friction force does not depend on the area of contact between the object and the surface. The coefficient of static friction is slightly greater than the coefficient of kinetic friction. Within rather large limits, kinetic friction is independent of velocity. Friction depends upon the nature of the surfaces in contact. Now, friction can be two types, dry friction and fluid friction. Dry friction is a friction that exists when two dry surfaces move relative to one another. It also known as Coulomb friction. Fluid friction is a friction that exists between two adjacent layers in a fluid that are moving at different velocities. And dry friction again can be two types, static friction and kinetic friction. Static friction is the force of friction on an object that is not moving. If we push on a stationary block and it doesn't move, it's because of static friction, which is equal and opposite to the our push. Kinetic friction is the force. Kinetic friction is the force that resists the relative movement of surfaces once they are in motion. Direction of different kinds of forces. There are many forces that can be acted on an object, especially gravitational forces, reaction force, and friction force. Gravitational force will always act down to the surface, while reaction force will act upward to the normal of the surface. Friction force will act opposite to the direction of motion. In the first case, the object will move to the right, so the friction force will act to the left. In the second case, the forces is at angle, but the friction force will act opposite to the motion, which is left. In the third case, the object will move downward with the tilted surface, so the friction force will act upward with the tilted surface. Advantages of friction. There are many advantages of friction. Friction enables us to walk freely. It helps us to support ladder against a wall. Objects can be piled up without slipping, or brakes of vehicles work due to the friction. Disadvantages of friction. Friction produces unnecessary heat, leading to the wastage of energy. A lot of money goes into preventing friction that and the usual wear and tear caused by it by using techniques like greasing and oiling. Forest fires are caused due to the friction between tree branches. Effect of applied load on coefficient of friction. The coefficient of friction as a function of load for a steel slider on unlubricated aluminum is shown in first figure. The coefficient of friction remains essentially constant, although the load is varied by a factor of 10 to the power 5. However, in the case of materials with surface field which are applied or provided by the reaction with environment, the coefficient of friction may not remain constant as a function of load. For example, in the second figure, copper sliding on copper in air, the coefficient of friction is low at low loads, and the transmission occurs to a higher value as the normal load is increased. In the third figure, coefficient of friction is decreased with increasing normal force for nickel aluminum alloy in air. Effect of hardness on coefficient of friction. The figure shows relation with hardness and normal load for silicon, silica, and natural diamond. In the case of diamond, transmission does not occur in the load range because of its very high hardness, but silicon and silica coating starts to increase above some critical load.
1
Effect,
minute. ওকে শুরু করো থেমে আসো কেন
effect of area of contact on coefficient of friction. For wooden sliders on steel surface, apparent area of contact was varied by a fraction of about 250 and the normal load was kept constant. The coefficient of friction remains constant, proving Amontona's second law. Effect of sliding velocity on mu. The coefficient of kinetic friction as a function of sliding velocity genuinely has a negative slope. The slope of friction velocity curve is small. It's usually small. Basic mechanism of sliding friction. Basic mechanism of sliding follows deformation. Deformation is two types, microscopic and macroscopic. In microscopic deformation, asperity contacts in the tip and create adhesion. In macroscopic deformation, not only tip contacted but a large portion of asperity area contact each other. This was my presentation. Thank you.
পয়েন্টার ইউজ করবা পয়েন্টার ইউজ করো নি তুমি ঠিক আছে রাকিব হাসান
জি স্যার
রোল নাম্বার 30
Yes, sir.
হ্যাঁ মহিদ হাসান স্লাইড শো
Sir, আমি 31, roll 39 মনে হয়।
রোল 39 আচ্ছা 31 শুরু করো
Hello everyone, my name is Fahri Hassan Bhai and this presentation is about friction. Friction is defined as the resistance to motion during sliding or rolling when one solid body moves tangentially over another. This resistive tangential force is called the friction force. There are two main types of friction. They are dry friction and fluid friction. So dry friction is the tangential component of the contact force when two dry surface move or tend to move relative to one another. It is also known as Coulomb friction. And fluid friction is the tangential component of the contact force between adjacent layers in a fluid that are moving at different velocities relative to each other. Now, if the solid bodies are loaded together and a tangential force is applied, then the value of the tangential force that is required to initiate motion is the static friction force. It may take milliseconds before relative motion is initiated at the interface. The tangential force required to maintain relative motion is also known as the kinetic friction force. Static friction force is either higher than or equal to the kinetic force. One important thing to note is that the friction is not a material property, rather it is a system response. Surface contaminants or thin films can affect friction. So without friction, it would be impossible to walk, use automobile tires or pick up objects. In some machine applications, friction is intentionally maximized, and it also comes with some downsides. Friction is undesirable due to energy loss and wear of moving surfaces in contact. So friction is minimized in these cases. There are two basic laws of intrinsic friction. These laws are referred as Emonton's law. The first law states that the amount of friction is proportional to the normal force exerted by the surface. W is the normal force. And the second law states that the friction force or coefficient of friction is independent of the apparent area of contact between the contacting bodies. These two bodies have the same coefficient of friction regardless of their physical size. Also, a third law is sometimes added to these two laws, which states that the kinetic friction force is independent of the sliding velocity once motion starts. So the coefficient of friction as a function of load for a steel sliding on aluminum in air is shown in this figure. Coefficient of friction remains constant although the load is varied. In the case of materials with surface films, the coefficient of friction may not remain constant as a function of load. For example, copper sliding on copper in air, the coefficient of friction is low, and at low loads, and the transition occurs to a higher value as the normal load is increased. So reasons for this low friction are copper readily oxidizes in air, so that at low loads, oxide films effectively separates the metal surface, and there is little or no metallic contact at all. And the oxide film has low shear strength. At high loads, films break down, resulting in intimate metallic contact, which is responsible for high coefficient of friction and surface damage. And for this stainless steel on nickel aluminum alloy in air, coefficient of friction decreases with normal load due to plastic deformation and presence of large quantity of wear debris. Basic mechanism of sliding friction. Adhesion, when two flat surfaces are placed in contact under load, the contact takes place at the tip of the asperities. Discrete contact spots are formed. When these two surfaces move relative to each other, a lateral force is required to share the adhesive bonds.
4 minutes.
Deformation. Two types of interactions can occur during sliding of two surfaces with respect to each other. The macroscopic interaction, where primarily plastic deformation and displacement of the interlocking surface asperities are required, and the macroscopic interaction, where asperities of harder material result in fracture, tearing, or fragmentation. And that is all. Thank you.
Okay, next. ক্লোজ করো তোমারটা।
হ্যালো, আসসালামু আলাইকুম।
তোমার রোল নম্বর 33 না? 33 আবরার ওয়াসিফ। হ্যাঁ।
জি স্যার। Yes sir.
Okay, start.
Hello everyone. My name is Mohammad Abrar Wasif and my presentation topic is friction of materials. So let's start. Friction is not itself a fundamental force nor a conservative force. Actually, it is a resisting force that resists the relative motion of solid surface, fluid layers, and material elements against each other. Okay, so the result is that it converts kinetic energy into thermal energy. Actually, it converts work to heat. Okay, resistive tangential force which acts in the direction opposite to the direction of motion is friction force. Okay, here you can see the direction of attempted side and the friction force, and it is white and it is normal force. Okay, types of friction. There are two main types of friction: dry friction and fluid friction. Okay, dry friction, we can see here dry friction, some image. The dry friction that opposes the relative lateral motion of two solids is a surface in contact. Here you can see contact and motion, and dry friction occurs. And fluid, now fluid friction. Fluid friction describes the friction between the layers of viscous solid that are moving relative to each other. Okay, some other friction, the lubricated friction. It is a case of fluid friction actually, and it's lubricated fluid separates two solid. And skin friction, it's the force resisting the motion of fluid across the surface of body. Internal friction, actually, it elements making up the solid materials will undergo deformation. Okay, now let's talk about static friction. It's the friction between the two or more solid objects that are moving relative to each other. Solid friction must be, or this static friction. Okay, this force of static friction Fs, it must be overcome by an applied force before an object can move. Okay, the kinetic friction. Kinetic friction is actually dynamic friction, and static friction occurs when the two objects are moving relative to each other and rub together. Tangential force required to maintain relative motion of kinetic and dynamic friction force. So its force of kinetic friction Fk, Fs should be greater than Fk to move an object. Here you can see the force kinetic for static friction force that rises frequently, then sudden drops for kinetic friction force. Now, some benefits of friction. You can work freely, support ladder, transfer from one energy to another, sleeping, breaks of wheels. Okay, you can see some our cricket players shows friction match sticks and drive automobiles, paper, and some demerits of friction in resist the motion, wear and tear of machines, decreases the life expectancy. Say the brake pad and some wear out, say stones wear out, and friction causes heat. Say some brakes causes heat. Okay, solid contact, low sliding friction. Three law: Hamilton's first law, the force will be proportional to applied load. The second law, Hamilton's law, the force independent of the apparent area of contact. And Coulomb's law of friction, independent of the sliding velocity. Next is still sliding on aluminum air. See some coefficient of friction is constant from variation of normal load. For materials with surface films, nu may not remain constant as a function of load.
1 minute.
Sorry. Copper sliding on copper in a fast low loads এর জন্য constant, then transition acquires for higher load, then higher load আবার constant হয়ে যায় because first হচ্ছে oxidized হয় low load এ, then oxide film directly separates, then little or no true metallic contact, then oxide film has low shear strain that is new decreases, then again high loads film breaks into resulting intimate metallic contact and high new and surface damage. Still on nickel chip aluminum alloy in air, high load new decreases, and this is because plastic deformation and presence of a large quantity of wet debris. Now new for sharp diamond, see diamond remain unchanged here, diamond wet depth remain unchanged, but silicon oxide and silicon coating increases with load, here increases with load.
স্টপ, স্লাইড গুলো দেখাও, দেখে যাও পরে স্লাইড। যাও যাও, তুমি আবার ক্যালকুলেশন নিয়ে আসছো কেন?
ক্যালকুলেশন করিনি, জাস্ট পিকচার।
আচ্ছা, তারপরে শেষ কোথায়? থ্যাঙ্কস, শেষ। ওকে, রোল নাম্বার 33 আবার হোয়াটসঅ্যাপ গেল। 34 সিরাজুল মনিরা।
Yes, sir.
হ্যাঁ, স্টার্ট।
Assalamu alaikum. I am Siraju Munira and today I am going to talk about friction of materials. These are the topics I will go through in this presentation. Basically, friction is the resistance to motion during sliding. Here is a picture of a box being pushed to the right direction. It feels a resistive force towards the opposite direction, which is called the frictional force. And this phenomena is called the friction. Here, the angle between the normal load W and the frictional force or direction of motion is always 90 degrees. We can classify friction based on different things. Like based on the type of motion, friction can be of two types, sliding and rolling. Sliding occurs where two surfaces are rubbed against each other, and rolling occurs where an object rolls on the surface. Another main types of friction are dry and fluid friction. Dry friction exists when two dry surfaces move relative to one another, and fluid friction exists between two adjacent layers in a fluid that are moving at different velocities. When solid bodies are loaded together, the force required to initiate motion is the static friction force. And here we can see from this curve that it takes a few milliseconds before the initiation of the relative motion. And after the motion is started, the force required to maintain the relative motion, it is called the kinetic friction force. And the static friction force is either higher than or equal to the kinetic friction force. This is because a strong bonding occurs between the interfaces for being in the static state for a long time. Friction is called a necessary evil because it has both benefits and demerits. Applications of frictions in our daily life includes walking, cycling, driving, etc. And also brakes of vehicles work on the basis of the friction theory. And these are the disadvantages of friction, like it causes a lot of energy loss and also produces unexpected heat. Also, bearings and other moving components experience wear because of friction. There are three laws for solid-solid contact in sliding friction. The first law is this: F equals to mu W, where mu is the coefficient of friction. This is another expression of the first law when the body is on a plane with inclination angle theta. This is the picture of that case. The second law says that friction is independent on the apparent area. So two bodies, regardless of their physical size, have the same mu. These two are the basic laws, which are called the Amonton's law, and these are always applicable and generally obeyed. This is the third law, which says that kinetic friction is independent of the sliding velocity after the motion has started, and this law is not generally valid. Here is a graph of mu k versus velocity, where we can see that mu k has a small negative slope because it changes only by a few % for a change in velocity. Now we will see the effect of normal load on coefficient of friction. The first example is steel sliding on aluminium. Here the coefficient of friction is constant for a large variation of normal load. This is because there is no change at the interface. New changes when the material is with surface films or the interface is changed. This is an example of a material with surface films. For copper on copper, at low loads, the situation here is the copper readily oxidizes and forms copper oxide, which has a low mu, and it separates the surfaces. And at higher load, we can see that there is coefficient of friction high but constant. This is because films break down because of high load, and it results in intimate metallic contact. These are the curves for sharp diamond tips sliding on smooth silicon, silica, and natural diamond. Both coefficient of friction and wire depth increases with increasing load for silicon and silica, but no transition occurs in case of diamond surface because of its very high hardness.
4 minutes.
Wooden slider on steel supports Amonton's second law. Here we can see that coefficient of friction is constant for apparent area of contact varied by a factor of 250. But coefficient of friction doesn't remain constant for soft material like polymers because the surface is very smooth and clean, and so the apparent area is almost equal to the true area. Now we will see the mechanism of sliding friction. The adhesion mechanism is the two flat surfaces are placed on contact and contact takes place at these asperities and load being supported by the deformation of the contacting asperities, which leads to the formation of discrete contact spots. And here rupture occurs at the weakest region. Adhesion is decreased by decreasing surface interactions and by the presence of fluid film like air, water, lubricant, etc.
Stop. Slide below. देखिए जाओ. Go ahead. Okay. Okay, thank you. Roll number 35. Mashur Rahman Mehna.
স্যার 35 এর ডিভাইসে প্রবলেম, তো ও আজকে দিবে না।
আচ্ছা, তাহলে আমি ব্যাকে যাচ্ছি। ব্যাকে হচ্ছে রোল নাম্বার 4 আবরার।
Yes, sir.
হ্যাঁ।
দেখা যাচ্ছে?
হ্যাঁ, যাচ্ছে।
Right, আমি start করছি। Good morning, my name is Abrar and I will be presenting on friction of materials. So friction is defined as a resistance to motion either during sliding or rolling, and the frictional force is tangential to the direction of the applied force. Now there are various ways to classify friction based on the mediums involved. If there are two solid surfaces, it's dry friction. If it's a friction between two internal layers of a fluid, it's fluid friction. Depending on the mechanical motion, if it's translational motion, it's sliding friction. If there is a rotational motion, it's rolling friction. And depending on the nature of the relative motion, so for example, if the objects are in contact and there is no relative motion, it is called static friction. And if there is relative motion, then it is called dynamic friction. Now, friction is largely affected by the presence of surface contaminants such as thin films, which are basically formed by oxidation of the metal at the surface. Besides thin films, there can also be absorbed molecules and particulates that create a lot of surface roughness. As a result of this, two materials in contact form an adhesion by interlocking at the surface. And therefore, when we try to move a material, we have to first overcome this static frictional force before motion can be achieved. And then in order to maintain the motion against the applied tangential frictional resistance, we have to maintain a constant kinetic friction. And generally, this kinetic frictional force is lower than the static frictional force. Now, friction has its benefits. We can move automotive tires, can have traction on roads due to the presence of friction. But there are also demerits such as energy loss and wear. So for example, when gears are used to transfer energy from one part of a machine to another, the presence of like friction or wear at the teeth of the gears can cause energy loss and inefficiencies. Now, the laws of sliding friction are basically, there are three laws, two of which are called Amonton's two basic laws. The first law basically defines the static friction for an object that is sliding on an inclined plane. The second law says that the friction is independent of the apparent area of contact, something we will explore later on. And the third law says that the kinetic friction is often independent of the sliding velocity. So let's look at this first example. We have steel sliding on aluminum in air, and we see that when we apply load, there is no change in the coefficient of friction. So in this case, the coefficient of friction is independent of the applied load. But in another case, we can see that when we increase the normal load, the coefficient of friction actually increases. What's happening here is when copper is sliding on copper, initially there is a copper oxide oxidation at the surface, and these oxide films slide on oxide films, and the coefficient friction of the oxide is lower than the coefficient friction of the metal. But as we increase the load, the oxide films get broken away and weared away, and the metal starts sliding on the metal, and the coefficient of friction increases. But the opposite case can also happen, where we increase the load, the coefficient of friction decreases. This happens when stainless steel slides on nickel aluminide, and because they're both hard, the debris that is formed is spherical, and this spherical debris provides a rolling motion at the interface, which reduces the coefficient of friction. Further examples of debris is when diamond is sliding on diamond. Because they have the same hardness, no debris is created, and as a result, the increase of load does not change the coefficient of friction. But when diamond slides on silica, debris is created because silica is softer, but this debris is not spherical, and therefore it blocks the motion of the sliding motion, and when we increase the load, the coefficient of friction actually increases. Finally, we said that it was the coefficient of friction is a function is not dependent on the apparent area of contact. This is true, for example, for wooden sliders, as shown in this case. But in certain instances, like soft materials like polymers that have very smooth and clean surfaces, the apparent area can actually become equal to the true surface area, in which case the mu can depend on the true surface area. But for other materials, it does not. Now, there are two major mechanisms of sliding friction: adhesion and deformation. To understand this, look at this figure. This is the contact surface of two materials where you have surface roughness and asperities. So the point at which the asperities contact the asperities of another surface, that's called like a contact point. And there's an adhesion bond that forms there, but there is also bonding within the metal. Now, during sliding motion, if this adhesive bond is weaker than the bonding within the metal, then the rupture will basically happen along this contact point, and this will be basically called the adhesion mechanism of sliding. But if the metallic bond is weaker than the adhesive bond, then the rupture will actually happen along the metal, and a portion of the softer material will get cleaved off. This is called the deformation mechanism. So for adhesion, we have two expressions. I skipped the derivation for brevity. So there's adhesive friction for dry surfaces, which is mu A tau A over PR, which is the mean real pressure. And for when there are liquid films, there is an extra term which is called alpha, which denotes the fraction of unlubricated area. So from this, we can get some conclusions. For example, adhesion decreases by decreasing the surface interactions, because tau A decreases, mu A decreases. The presence of fluid film reduces adhesive friction, because when fluid film is increases, the alpha fraction goes down, which means 1 minus alpha increases. So the contribution of the liquid shear strength increases. Now, liquid shear strength is lower than the solid, therefore the overall friction decreases. And finally, in vacuum, because you don't have liquid, the friction coefficient increases. Now, deformation mechanisms are basically two types: microscopic and macroscopic. For microscopic deformation, the interlocking happens only at the contact of the asperities, and there's very thin region in which the deformation happens, and the volume cleavage happens. But in macroscopic, there is large area surface contact. Therefore, when there is relative motion, the larger groove basically plows through and causes massive volume deformation. And this can also happen due to asperity, and also happen due to the presence of debris. Thank you.
Okay. Thank you very much. Nice video.